Okay, so finally we get to talk about PyPy. Well, I thought that by now you would understand everything about PyPy, but well, never mind. I mean, mediocre programmers don't need to understand PyPy. You can just use it. So, a few words about myself. I'm a PyPy core developer. I'm working on NumPy support. And I'm a mediocre programmer. Well, there are limits to the amount of concepts and ideas I can have in mind at the same time. And when it comes to PyPy, if I were to try to keep in mind everything that makes up PyPy, like the JIT compiler, the garbage collector, well, all the tool chain, well, I wouldn't be able to do anything with Python. I wouldn't have any space left in my mind. So I'm here to tell you that that using PyPy is actually easy. So, what is PyPy? The elevator pitch is that PyPy is a fast, compliant, alternative implementation of the Python language. In other words, it is just like CPython, the reference implementation. So just like CPython, but faster, and that's it. Well, actually, Guido van Rossum described it quite well, I think. So if you want your code magically to run faster, you should probably just use PyPy. And that's the whole purpose of PyPy. And, well, the talk is about explaining exactly what just use PyPy means concretely. To use PyPy, first order of business, is to install it. And with CPython, we don't have to think about installing it. It's everywhere. With PyPy, we have to think a little about it. Fortunately, we only have to think about it once. Or, yeah, basically just once. So, the recent version history is here. PyPy and its ecosystem evolve rather quickly. Yeah, we had 2.4.0 1 year ago, then 2.5.0 in February, 2.5.1 in March, 2.6.0 in June, and 2.6.1 just a few weeks ago. Pretty much each of these versions had significant performance improvements. And there were a few user-visible changes in some of these versions, particularly so the standard library for 2.7.9, which changed things in SSL. I mean, it's just the same standard library as in regular Python. So same changes. And then there were important changes in CFFI. Talk more about CFFI later. And at this point, I should say a few words about Python 3. There is a PyPy version that implements Python 3. However, the last release was a year ago, so it's a bit lagging behind. And the other issue is that it implements 3.2, which I guess most people don't support anymore. Like I see most libraries supporting only from 3.3 on. I guess If you have a choice, just use PyPy, the Python 2 version, not PyPy 3. Let's go back to installation. There are several options. If you use your package manager to install PyPy, well, like this just did, you need to be careful about what version you get. Some distributions ship quite old versions of PyPy. So check that. So for instance, on Ubuntu LTS, I think the version is like 2.3 or something, so it's really old in PyPy terms. But for Ubuntu, there is a PPA which has the recent versions. Other option, you can just get the binaries directly from the PyPy site. The thing to be careful there is that if the thing you download hasn't been compiled for your specific OS, for your specific distribution, you may have compatibility issues with things like libc and so dynamic libraries on Linux. It's a mess. And that's the reason why there is a portable PyPy distribution, which includes all the dependencies of PyPy, and you just download a single archive which contains all the dependencies. So therefore you can use that on every Linux distribution. And there's a fourth installation option, which I'm not writing down because it's not a good idea. It's to install from source, to compile it yourself. So it's, well, it's fiddly, and it takes 5 gigabytes of RAM. Takes about an hour on a recent computer. So don't do that unless you're sure you have to. But so, if you have one of these binaries, you're almost ready to go. There's just one more thing you should do, and it's to use virtualenv. Because otherwise you risk getting confused between things that are installed for your system Python and the thing you want to install on PyPy. So put PyPy in a virtualenv, activate the virtualenv, of course. There's one trick here, which is to use Python -m pip to be completely sure that you're using the right Python version, that you're not picking up some other Python from somewhere else. Okay, so I could almost stop the talk here, because now with this, you have everything to run Python programs. It's very likely to just work and to be faster than CPython without you having to do anything. However, if you have a larger, any sort of large application, you're likely to have problems. You're likely to see something like this the first time you try to install your application. And the issue is the C extensions. All these packages we rely on in the Python world, which are written in C and compiled and use the C API of CPython. So that doesn't usually work in PyPy. Fortunately, there is an easy answer to an easy answer to that problem. Just use CFFI. Yeah, that's it. So there are other options for dealing with C extensions. The first one is that if you can, and you're using PyPy, just rewrite your C extension in Python. PyPy is fast enough that you don't need to use C for performance. The reason you have to use C in PyPy is if, well, basically when you want to access an existing library. Other possibilities. So CPyX is the emulation layer for the C API. So PyPy comes with C headers, with python.h. And you can try to compile against that. However, this emulation layer is slow and it's incomplete. So if it works, it's fine-ish, but it's not very likely to work. Python uses CPyX, so you have sort of the same problems, except that it's at least Python knows what it can use. So Python works, but it will be slow. C-types, well, C-types works, but just don't use C-types. It's bad. The CFFI is better. I mean, if you want to use C-type, just use CFFI. And finally, there's a crazy project which is called the PyMetabiosis, which solves the problem of C extensions by embedding CPython inside PyPy. So, then you just use this embedded CPython as a library. And if you have something that works only on CPython, then you send data to CPython, which talks to the C extensions, and you can get the results back into PyPy. Okay, so let's go back to CFFI, which is really what you should use. The basic principle of CFFI is that since you're interfacing Python and C, you hopefully already know both C and Python. And well, you shouldn't have to use anything else. And therefore, CFFI has a very minimal interface, which tries not to get in the way, and you describe C concepts using C code. That approach is quite popular now. There are more than 1 million downloads per month. So it's like in the top 10 of most downloaded packages on PyPy. CFFI comes bundled with PyPy, and this close integration with PyPy is what enables it to work, to be fast on PyPy. Yeah, but the consequence of that integration is that for each version of PyPy, you have a specific version of CFFI. So once you have PyPy, you cannot install another version of CFFI. You'd have to change your PyPy. So performance good on PyPy, as I said, and it's fine on CPython. It's not an issue. Right. So let's look a bit at how it looks. Oops, sorry, that's not what I wanted to show right now. Yeah. So. So the principle, well, there are nowadays two modes of operation in CFFI. One is, well, for development, I guess, purposes. So you tell CFFI which C functions you want to expose. Then you DL open the library, and then you can access the C functions directly, and you have methods like this FFI.new to manipulate C objects. Now, since once again, since CFFI version 1, so since a couple of months ago, you can separate the phase where you describe the library and the phase where you use it. And this means that you get CFFI will generate an extension for you that wraps the library, and it's much faster at runtime to load that. Okay, so that's it for CFFI. Now, where was I going with this? Yeah, the behavior of PyPy is not exactly the same as the behavior of CPython. So you have differences, so it's important differences, like the fact that if you do obj non: none, it behaves differently than if you do obj slice with just a colon. So yeah, this is not actually important, but there are a lot of these small differences, like with when you do when you compare integers with is, like the internal types of internal methods. Sorry, but this is well, it's not something you're likely to encounter, but yeah, you have those. Well, you need to test for those differences, because in a big enough project you'll encounter them. So the big difference in terms of behavior between CPython and PyPy is to do with garbage collection. So CPython is garbage collected, which means that when you create a file object and it goes out of scope, it's automatically closed. On PyPy, it's not the case. The file object will remain open for quite a while. Therefore, it's important to be sure to always close your file object, your sockets, etc. So you can do that if you have Wizblocks. It's the easiest way. And yeah, and don't use del. Well, that's actually it. Once you have dealt with C extensions and the small differences between PyPy and CPython, you're done. So yeah, I'll skip that. So if you want to magically run your code faster, the recipe, just install a recent PyPy. At least 260, because you'll have then the newer CFFI. Use CFFI, just make sure that you test for those small differences, and you're done. Thank you.
Questions, anyone? Stand. Stand, please.
Thank you for your talk. Just a question related to NumPy. Just the
Yes.
slide you skipped.
Yeah.
I tried to read, but it was too fast.
Ah, sorry.
Yeah, I use NumPy a lot with CPython. So what are the implication of using PyPy with NumPy regarding the NumPy performance, given that NumPy can be compiled against different low-level libraries like Atlas, or depending what you do, but what is the consequence of using PyPy against NumPy then?
The main issue is that our implementation of NumPy is incomplete. We can't, NumPy can't work as is on PyPy because it uses a lot of the C API. So that's why we had to re-implement it, and it's still incomplete. But in terms of performance, I think it's roughly the same. Some things are slower, some things are faster. You'd have to test. In regards Atlas, we actually link them. And we actually implement like lineage using CFFI to wrap Atlas, BLAS, or whatever.
Questions?
Hey, a couple of years ago I saw a news article about PyPy on Android and ARM devices, but haven't heard anything since. Is that still happening, do you know? Or
On Android?
And other ARM devices?
Well, on Android, I don't know. But PyPy works on ARM, at least.
Great.
So the processor is not an issue, and it has a JIT, and it's quite efficient. It actually there's bigger difference between PyPy and CPython on ARM than on x86.
Fantastic.
But I don't think that we have an Android version.
Anyone else? Questions?